According to NFPA 70, the National Electrical Code, Section 110.26 states that electrical equipment must be accessible without removing obstacles, such as closed doors. Section 404.12 states that panel boards must be accessible without having to open or remove any part of the building structure. Panel boards must have a clear working space of at least 36 inches in front and 30 inches wide according to NFPA 70, the National Electrical Code, Section 404.8. Workspaces around electrical equipment must be large enough to permit maintenance. Electric heaters are not typically classified as junction boxes, as junction boxes are used to connect multiple wires together, whereas electric heaters are a type of electrical equipment. For variable frequency drives, also known as VFD, NFPA 70, the National Electrical Code, Section 430.24 states that VFD must have a clear working space in front and behind for maintenance and servicing. The specific clearance distance depends on the manufacturer's instructions. NFPA 70, the National Electrical Code, Section 110.26 phone says that workspaces around electrical equipment must be large enough to permit maintenance. The clearance requirements for electrical equipment contain inside heating, ventilation, and air conditioning, also known as HVAC units, to apply. The size of the HVAC unit does not exempt electrical equipment from code compliance. The fact that a door needs to be closed for maintenance access does not eliminate the violation. It is recommended to modify the HVAC unit to allow access to the electrical panel without having to close the door. Another option is to install a remote panel or switch for the heater to eliminate the need for direct access to the panel inside the HVAC unit. It is important to ensure that all other electrical equipment within the HVAC unit has adequate clearance for maintenance. Let's delve deeper into the specific National Electrical Code requirements. Section 110.26 addresses spaces about electrical equipment operating at 600 volts, nominal, or less to ground. This section is crucial for ensuring the safety of personnel who may be working on or near electrical equipment. The code specifies minimum dimensions for the depth of the working space and the direction of access to the equipment. These dimensions vary based on the voltage to ground and the conditions present on the opposite side of the working space. Condition 1 is where there are exposed live parts on one side and no live or grounded parts on the other side of the working space, or where there are exposed live parts on both sides effectively guarded by insulated materials. Condition 2 is where there are exposed live parts on one side and grounded parts on the other side. This condition typically requires a greater working space depth than Condition 1. Condition 3 is where there are exposed live parts on both sides of the working space and these parts are not guarded. This condition requires the greatest working space depth. The code provides a table, typically Table 110.26 AON, that outlines the specific working space depths required for different voltage levels under each of these conditions. It is essential to consult this table to determine the appropriate working space for a given installation. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. This ensures that there is adequate room for personnel to maneuver and perform their tasks safely. The height of the working space must be at least 6.5 feet, or the height of the equipment, whichever is greater. This provides sufficient headroom for personnel to work comfortably and avoid accidental contact with energized parts. The working space must be clear and unobstructed. This means that there should be no pipes, ducts, or other equipment located within the working space that could impede access or create a hazard. Section 110.26b addresses access and entrance to working space. This section requires that there be at least one entrance to the working space and that the entrance be of sufficient size to allow personnel to safely enter and exit. For equipment rated 1200 amps or more and over 6 feet wide that contains overcurrent devices, switch or control devices, there must be an entrance at each end of the equipment. Section 110.26c addresses illumination. Adequate illumination is essential for safe working conditions. The code requires that the working space be adequately illuminated to allow personnel to clearly see what they are doing. Section 110.26d addresses the headroom. The minimum headroom required in working spaces around electrical equipment is 6.5 feet. Section 110.26e addresses dedicated equipment space. This section requires that the space above and below electrical equipment be dedicated to the equipment and not used for other purposes. This helps to prevent damage to the equipment and ensures that there is adequate space for maintenance and repairs. Section 110.26f covers dedicated equipment space and requires that the space equal to the width and depth of the equipment and extending from the floor to a height of 6 feet above the equipment or to the structural ceiling, whichever is lower, must be dedicated to the electrical installation. No piping, ductwork, or other equipment foreign to the electrical installation is permitted in this zone. Regarding Section 404.8, which covers accessibility and grouping, it states that switches and circuit breakers used as switches must be so arranged that the center of the grip of the operating handle of the switch or circuit breaker, when in its highest position, is not more than 6 feet 7 inches above the floor or working platform. The code also addresses the grouping of switches, circuit breakers, and other control devices. These devices should be grouped as much as possible to make it easier for personnel to operate and maintain the equipment. Section 430.24 specifically focuses on conductor sizes for motor circuits. It requires that the conductors supplying a single motor must have an ampacity not less than 125% of the motor's full load current rating. This requirement ensures that the conductors are capable of carrying the motor's load without overheating. The specific clearance requirements for VFD will vary depending on the manufacturer's instructions. Therefore, it is essential to consult the manufacturer's documentation to determine the appropriate clearances for given VFD installation. These instructions will typically specify the minimum clearances required around the VFD for ventilation, access, and maintenance. In addition to the manufacturer's instructions, local codes and regulations may also impose specific clearance requirements for VFD. It is essential to check with the local authorities to ensure that the installation complies with all applicable codes and regulations. The NEC doesn't explicitly define the term junction box in the way it's being considered here, but it's important to understand what a junction box is according to the NEC. A junction box is essentially an enclosure where electrical conductors are joined or terminated. The NEC provides specific requirements for junction boxes to ensure safety and prevent hazards. These requirements cover aspects such as the materials used for construction, the size of the box, the methods of securing conductors, and the protection of splices and terminations. Article 314 of the NEC covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. This article provides detailed requirements for the installation and use of these enclosures. Some key requirements include the following. Junction boxes must be made of durable materials such as metal or non-combustible plastic. The size of the junction box must be sufficient to accommodate the number and size of conductors being joined or terminated within the box. Conductors must be securely fastened to the junction box to prevent strain on the connections. Splices and terminations within the junction box must be properly insulated and protected. Junction boxes must be accessible for inspection and maintenance. Considering the scenario of an electric heater contained within an HVAC unit, it's important to consider how the NEC applies to this situation. Even though the heater is located inside the HVAC unit, it is still subject to the requirements of the NEC. This means that the heater must be installed in accordance with the applicable provisions of the NEC, including those related to wiring methods, overcurrent protection, grounding, and clearances. The NEC also addresses the installation of electrical equipment in specific locations, such as those that are damp or wet. If the HVAC unit is located in a damp or wet environment, the electrical equipment within the unit must be suitable for the environment. This may require the use of watertight or weatherproof enclosures and fittings. Section 110.3b of the NEC requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means that if the heater or any other electrical equipment within the HVAC unit is listed or labeled, it must be installed and used in accordance with the manufacturer's instructions. The NEC doesn't specifically address the clearance requirements for electrical equipment inside HVAC units. However, it does provide general clearance requirements for electrical equipment in Section 110.26, which applies to all electrical equipment operating at 600 volts or less. These clearance requirements are intended to provide adequate working space around electrical equipment for safe operation and maintenance. It is important to note that the clearance requirements in Section 110.26 apply to the electrical equipment itself, not the HVAC unit. This means that the HVAC unit cannot obstruct the required working space around the electrical equipment. If the HVAC unit does obstruct the required working space, it may be necessary to modify the unit or relocate the electrical equipment to comply with the NEC. Regarding the potential classification of the heater as a junction box, it is unlikely that the heater would be classified as a junction box. A junction box is typically used to provide a convenient and safe location for joining or terminating electrical conductors. While the heater may contain some internal wiring and connections, its primary function is to provide heat, not to serve as a junction point for conductors. Therefore, the heater would likely be classified as an electrical appliance or equipment rather than a junction box. In conclusion, when installing electrical equipment inside HVAC units, it is essential to comply with all applicable requirements of the NEC, including those related to wiring methods, overcurrent protection, grounding, clearances, and environmental suitability. It is also important to consult the manufacturer's instructions for any listed or labeled equipment. By following these guidelines, you can ensure that the installation is safe and compliant with the NEC. Now, let's discuss some common misconceptions regarding electrical clearances. One common misconception is that electrical clearances are only necessary for high voltage equipment. In reality, electrical clearances are required for all electrical equipment, regardless of voltage level. This is because even low voltage equipment can pose a shock hazard if not properly installed and maintained. Another common misconception is that electrical clearances are only necessary in commercial or industrial settings. In fact, electrical clearances are required in all types of buildings, including residential buildings. This is because electrical hazards can exist in any building where electricity is used. Another misconception is that electrical clearances are only necessary during initial installation. In reality, electrical clearances must be maintained throughout the life of the electrical equipment. This means that it is important to periodically inspect electrical equipment to ensure that clearances are still adequate. Finally, another misconception is that electrical clearances are the only safety measure necessary to prevent electrical hazards. In reality, electrical clearances are just one of many safety measures that should be implemented to prevent electrical hazards. Other safety measures include proper grounding, overcurrent protection, and the use of personal protective equipment. Let's talk about specific situations you may encounter and how to address them. Situation number 1: limited space. In some cases, it may be difficult to provide the required electrical clearances due to limited space. In these situations, it may be necessary to use special equipment or techniques to reduce the required clearances. For example, you may be able to use insulated busbars or shielded cables to reduce the required clearances. Another option is to use a smaller electrical panel or enclosure. However, it is important to ensure that the equipment is still adequately protected and that the installation complies with all applicable codes and regulations. Situation number 2: obstructed access. In some cases, access to electrical equipment may be obstructed by other equipment or building components. In these situations, it may be necessary to relocate the equipment or modify the obstructions to provide adequate access. For example, you may need to move a pipe or duct to provide clear access to an electrical panel. Another option is to install a platform or a ladder to provide access to equipment that is located above the floor. Situation number 3: environmental conditions. In some cases, electrical equipment may be exposed to harsh environmental conditions such as moisture, dust, or extreme temperatures. In these situations, it is important to use equipment that is suitable for the environment. For example, you may need to use watertight or dust-tight enclosures to protect the equipment from moisture or dust. You may also need to use special cables or connectors that are designed to withstand extreme temperatures. Situation number 4: future expansion. When designing an electrical system, it is important to consider the possibility of future expansion. This means that you should provide adequate space for future equipment and wiring. You should also ensure that the existing equipment is capable of handling the additional load. By planning for future expansion, you can avoid costly and time-consuming modifications later on. Finally, let's discuss the importance of documentation and training. Proper documentation is essential for ensuring that electrical equipment is properly installed and maintained. Documentation should include detailed drawings, specifications, and operating instructions. It should also include a record of all inspections, tests, and repairs. Training is also essential for ensuring that personnel who work on electrical equipment are properly qualified. Training should cover all aspects of electrical safety, including the proper use of personal protective equipment, the identification of hazards, and the procedures for safely working on electrical equipment. By providing proper documentation and training, you can help to prevent electrical accidents and ensure that your electrical system is safe and reliable.